Alright, problems 13, 14, 15. Problem 13. This is an addition problem. 2p minus 5 over p squared plus 5p minus 6 plus 6 over 1. Okay, to find the common denominator, I've got to factor my denominators. So I'm going to factor this. Two numbers that multiply to give me 6, but subtract to give me 5 would be 6 and 1. You can't use 2 and 3 because they add to give you 5, not subtract. I want a positive 5, so it's got to be a plus 1 and a plus 6 and a minus 1. So my common denominator has to have everything that's represented on the bottom. So a p plus 6 is represented on the bottom. A p minus 1 is represented on the bottom. And a 1 is represented on the bottom, but 1 is irrelevant. But for giggles and grins, I'm going to write it. But it's irrelevant. You don't have to have it. It's understood. Okay? Here, I had the p plus 6, I had the p minus 1, so I had everything because 1 is irrelevant. So since I had everything, I don't have to change the top at all. It's like a fraction that you don't have to reduce. Okay? Now this one, I didn't have everything. All I had was the 1. So I'm going to have to add a p plus 6 to the numerator and a p minus 1 to the numerator. Okay? Because if I reduce this back, I'd have 6 over 1, which is what I had there. Okay, now I need to simplify the numerator. And I'm going to FOIL this out. I know what it is because it's right here. So I'm going to distribute a 6 through it. So that's going to be 6p squared plus 30p minus 36. Now I'm not FOILing back out the denominator because something might cancel. Okay? We just have to see. Alright, now let's simplify like terms on the numerator. I've got a 6p squared. 30p and 2p make 32p. 5 and 36 make 41. They're both negative. So I have 6p squared plus 32p minus 41 over p plus 6p minus 1. Now I have to see if this will factor. Okay, and for this I am going to use my calculator. So take your calculator, I got to grab mine. Take your calculator and multiply 6 times 41. Get whatever that is. So 6 times 41 is 246. And then we need the factors of 246 that would give me a 32. So I hit y equals and I do 246 divided by x. And then I do second and table, which is the graph button. And I'm looking for a pair that subtract, because it's a minus, to give me 32. So I'm looking for a pair that subtract to give me 32. Okay? 1 and 246, 2 and 123, 3 and 82. Well, 6 and 41 would give me 35. And I'm just looking for whole number pairs. And I do not see one. So that tells me that this is not factorable, so nothing else would cancel. If it would factor, I'd go ahead and factor it and see if anything else would cancel. But there's my final answer. Okay? All right, problem 14 is a subtraction problem. 4n over n plus 3 minus 6 over n minus 3. Okay, there's no factoring to be done because they're both already as low as they'll go, but I need a common denominator. My common denominator is going to have an n plus 3. It's also going to have an n minus 3. Whoops, it's not a plus, it's a minus. Okay, so compare. I had a 4n over n plus 3. The extra that I put on the denominator was an n minus 3, so I have to put an extra n minus 3 on the numerator. This is like multiplying by 1. Okay? Now let's do the second piece. I had an n minus 3 and a 6. That's what I had. But I have an extra n plus 3, so I got to put it up there. Now I am going to simplify. 4n times n is 4n squared. 4n times negative 3 is negative 12n. They have the same denominator, so I'm just going to make a big long vernaculum and write it underneath. Okay. Now, here's where people flub up. The minus goes to each piece. So 6 times n is 6n, but it's minus 6n. 3 times 6 is 18, but it's minus 18. And keep in mind, if they were negative, you'd have to change them to positive. The negative goes to each piece. Okay, now I do like terms. Four n squared minus 18n minus 18. Now I'm going to see if anything will factor. I see that I can pull a 2 out of there. Now look at this thing and let's see if it factors. 2 times 9 is 18. I need the factors of 18 that would subtract to give me 9. Well, 1 and 18 subtract to give you 17. 2 and 9 subtract to give you 7, excuse me. 3 and 6 subtract to give you 3. It's not 3 and 6 because it has to be a subtraction problem. So those are my only choices. So this thing won't factor, so nothing cancels. So I could have left my answer here, or I could leave my answer here. I will accept either one. Okay? Because 2n squared minus 9n minus 9 will not factor anymore. Okay? All right. Problem 15. Is a subtraction problem. 2 over 2a minus 5a over 3a minus 6. Okay? I said if anything would reduce it before you get started. So let's reduce that 2 and that 2 and make this just 1 over a. Okay? My common denominator has to represent everything that's in the denominator. So it's got to have an a. And it's got to have a 3a minus, I should have factored that. Sorry about that. All right, pull out a GCF. So my denominator has to have an a, it has to have a 3, and it has to have an a minus 2. Okay. Now, this one had the 1, or had the a, so it needs a 3, and it needs an a minus 2. And there was only a 1 up there, so 1 times 3 is just 3. Okay, now let me talk through that again, because I said it a little fast. This one had the a, so the things that I didn't underline were the extras, and they needed to go on top. Okay. Now this one had a 3, and it had an a minus 2. Here's what was already up there. It needs an extra a. I put an extra a on the bottom, so I had to put an extra a on the top. Can't cancel those a's because you haven't put the extra one up on the top yet. Okay, so now what do I have? Let's distribute out. I have 3a minus 2 minus, okay, this was what I already had. I put 2 marks on it. Here was the extra that I put up there. So 5a times a is 5a squared. Okay. Now, you're not used to seeing things in that order. You're used to seeing them like this. And remember the commutative property, order doesn't matter as long as you keep the signs with it. I would accept either of these, and this thing doesn't factor. I'll spare you that and let you know it doesn't factor, so there's nothing else that I can cancel. So I will take either one of these answers. All right, and there is 13, 14, and 15.